Hey, hello everyone. In this another session on IBM Maximo application suite, I'll be discussing two major applications that comes under Maximo application suite, health and monitor. Both of these applications are built for unique needs in the asset lifecycle management space. Health is built to calculate the health score of assets. It uses historical data to calculate the health scores. And looking at the health score, you can identify the remaining useful life for an asset, or you can determine various other actions, informed actions based on the health score that is projected by this health application. You can create custom dashboards and you can create your own metrics to look at data in a different way so that you get the informed decision at the end of the day. Monitor, on the other hand, is a bit more complex, and it used to perform real-time monitoring of assets and do anomaly detections, etc. It's an IoT integrated app. So the complexity is where this monitor application has to be integrated with various field devices, IoT devices or connected devices or edge data collectors. All these components needs to be connected to the mass monitor. But IBM has provided, or mass monitor comes with its own foundation, so that it makes a little bit easy for you to integrate with various devices, and each device is communicating in various protocol can be streamlined, and the data can be streamed seamlessly into the monitor application. We'll look into the architecture and the infrastructure requirement and some estimation example which will give you a good understanding to size the infrastructure requirement and to perform an optimized cluster deployment. Let's start with an architecture. So what you see here is a standard or typical architecture for Maximo application suite deployment. We have the OpenSHift container platform, Mass Core and MongoDB deployed. Mass Core and MongoDB are the core dependency for any Maximo application suite deployment. I have the manage, health and monitor application enabled and deployed. I have two databases, DB2 data warehouse and an asset DB. Asset DB is my ALM database. ALM is asset lifecycle management, or the managed database is a managed transaction database. This database can be Oracle, DB2, SQL Server, any supported database. In this case, I'm just focused on DB2. This is the DB2 DW database data warehousing. DB2 warehouse is a fully integrated data and API platform for storage and analytics of your IoT data. So DB2 warehouse or any DB2 database can run as a cluster within your cluster, and also it can be kept outside as a dedicated standard server. So in this example, you can see I kept it outside the cluster. And I recommend, and I always, my preference is to keep it outside the cluster. There are various factors that help by keeping it outside from your mass cluster. One example is maintainability, another one is performance, another one is kind of level of access that DBS can get without getting into cluster. But both of these can run within the cluster. Okay. So now you can see the manage is connected to your ALM or your managed database. Health is also connected to your managed database here. There is a dotted line you can see from manage and health pointed to DB2 data warehouse. What it indicates that you can choose to have single database for your manage, health and monitor, which is DB2 DW, and get rid of this asset DB, right? If you choose to do that. But if you are a customer who is just starting with manage and health and do not have a vision for monitor, or you have any other tool that we are currently using, it's ideal you can go with the standard DB2 edition or Oracle or SQL Server. You don't need to bring the data warehousing or data lake solution, because the monitor is not planned to install. There is no additional benefit you get by deploying manage into a data warehouse solution database. The only requirement here for DW is when you install monitor. Now here in the monitor case, you can see it's a little bit complicated components are there. Various different components are deployed under monitor. One is a Kafka. Kafka is a streaming service, data streaming, which is used by the internal data flow and other stuff, and this can also be extended for our customer or our own custom data integrations as well. Then we have the IoT tool. IoT tool can be used as a IoT device message broker for secure device registration. It's an important tool when you deploy monitor. This is the tool or the foundation that you get to connect various signal devices or IoT devices into monitor in order to ingest the data, also to perform certain level of analytics or massaging of data. Then we have the asset data dictionary component installed. This asset data dictionary component is mainly get installed when you install monitor or any application that is really required asset data dictionary. This service and related components will be get installed. But when you just go with manage health, you won't need it and you won't see it. But when you install monitor, asset data dictionary going to come and sit in your cluster. Then we have the internal integration. That is mainly used for the internal communication within the cluster and within each of the modules and stuff, so that we cannot generally tap into these integrations. Monitor deploys multiple ports. Close to around 20-25 additional ports will come. These are all services that are required by monitor to ingest the data, perform the analysis, and detect the anomaly and all those metrics that you see in the dashboard. All these calculated by various services that get deployed when you install monitor. Here again, you see here in the right corner, you can see a robotic arm and various IoT sensors connected to it, which again connected to a edge data collector and a gateway, which ingest the data into monitor. This is not part of the core architecture. I wanted to show you because when you size or infrastructure sizing of this monitor, we need to consider certain external factors like IO points. How many signal data or time series data hitting the monitor per minute, that is going to define your cluster size. How many worker node, how many core CPU, etc. needed. It depends not only on the number of users, it's going to be number of the IO points, right? There is a relation between all these. So in the coming slides, I will explain how the IO points is calculated. But this gives you an overall architecture diagram which shows the deployment of managed health monitor with all the required core component. There are additional components that is obviously services and components are required, but these are the key components required for the end-to-end implementation of health and monitor. So let's recap some logic about the health and monitor. What is the purpose of this application before we go into the estimation part? So health is designed to improve reliability of assets and locations. It improves the trust in your organizational ALM data. Health uses asset location historical information, like as I mentioned, the number of corrective work orders done, service request, and additional data points it uses to calculate the score of the asset. There are different score patterns or score levels. As an example, if you have an asset and you're performing corrective maintenance on that asset frequently, obviously that is not a good sign, and the health application can highlight as a risk because there is something really wrong with that equipment, because that's the reason why you keep doing that corrective maintenance. So corrective maintenance is not good in the health world. So it's like a red flag for you. So the health can bring those information into light in dashboards, and you can easily make a decision whether to replace or really find the root cause and fix it forever, something like that. It provides health score, criticality score, remaining useful life. All these data points you can see them see on the dashboard. You can create custom dashboards to bring additional data insights. And it also provides actions. You can create service requests, you can create plans of decommissioning assets. So all those additional features are available in health as well. Monitor, on the other hand, is real-time monitoring, right? It's based on time series signal data. There are sensors and IoT platform keep sending information into the monitor. Monitor uses all these data, churn through them and understand, look for anomaly in any of the signals, and they can either alert, take an action. It can also show you historical trends, that you can see whether an equipment is nearing to a failure point, right? So it looks at, take an example, if there is a robotic arm, it's supposed to turn. It's a robotic arm which does a critical welding, right? So the angle, the position is very critical, and every time a robotic arm moves 35 degree, the sensor measures that angle and reports that back to the monitor. And as times go, if there is any wear and tear comes, and if this has become a little bit 31 degree, 32 degree, it needs to be fixed, right? Because it cannot exactly weld that two components together if the angle is different. So before it become a bigger issue, monitor can show that trend, that means it is deviating from its fixed position, fixed angle a little bit. So you can do early maintenance or early corrective action so that it doesn't become a bigger issue later point in time. So monitors keep monitoring in real time. Health is using the historical data to give a health score. It's a really two different set of application, looking at two different thing, but use the same kind of data to predict. And also it both provides you capability to take actions based on real-time dashboards, calculated dashboards and matrices. Monitor connects to IoT sensors, SCADA and any other compatible systems. It can also look into the historian to see the historical trend. There are a lot of data integration that you can do with monitor. You can also integrate monitor with manage, and there are more new capabilities are coming into both of these applications. Now just take a look at the infrastructure for health and monitor. So here we are going to size the cluster properly to deploy health and monitor application. So in this scenario, if you remember when I discussed the architecture, I talked about two options to deploy health. One is the extension, another one is the standalone. Here I am just talking about extension, right? Not the standalone one. So if you deployed with manage as extension, consider the number of concurrent users for health, which is significantly smaller compared to the manage. So you don't see a lot of number of users required to access manage. This is some key people, some key reliability engineers or reliability people on your organization having access to that. So monitor calculation, the health capacity calculation is pretty simple. This is my point of view. IBM has different, IBM has recommended a little bit different. But from my experience, what I understand, if you have 5 to 10 users, consider one core CPU, 10 GB RAM. That means if you already sized manage and you want to enable health as extension, look at your current capacity. If you feel it cannot be accommodated, enough ports cannot be accommodated, remember health extension doesn't create any additional health ports or anything, right? It's part of manage. But the performance, the requirement of core CPU and RAM may be a little bit high. So the calculation here is, if you see you have 5 to 10 users that is going to get into the health application, just add one core CPU, 1 GB RAM, look at your cluster. If there is no enough memory, add a worker node. If not, just you should be fine. 15 to 20 users, again 2 core CPU, 16 GB RAM should be more than enough. Greater than 20 users, I really doubt why you need 20 plus users for health. If such scenario, again you have to take a look at that usage and optimize your number of worker nodes. Significantly, you don't have to scale up if you just deploying health and if you have a minimum number of users part of it. The monitor, on the other hand, is a little bit complicated, right? The users are a factor. Again, like manage, you don't get a lot of users who need access to monitor. It's same like health, only reliability engineers, couple of people in your organization may require access. So I'll say 5 to 10 is 5 to 10 or 15 to 20 is a maximum depending upon the organization size or the deployment size. So again, the monitor is not just based on the users that access, it's more on the number of devices connected, number of time series or signals data flowing into the system. So monitor estimate is based on IO points rather than concurrent users. So my approach here is purely based on the IO points, not on any concurrent user. I am assuming it's close to 10 users using monitor. I just go with IO points. So what is IO points? Each IO point corresponds to a data ingested or analyzed by monitor per minute. Okay, the per minute is important, right? Because it's the calculation of IO point is based on the estimated frequency per minute. The amount of IO points corresponds to the infrastructure requirements for mass monitor. So you can see a table I've given here. Is a t-shirt sizing, extra small, small, medium, and large. And I kind of put it here. If it's extra small, if it is 1000 IO points, you call it extra small. Is 50,000 IO points, you call it as a medium size monitor deployment. And 100,000, I haven't seen any large deployments, but if it's required, again you have to calculate based on your IO points, right? You have to calculate how many IO points comes. So there is a formula. I'll be explaining how the IO points are calculated. But coming back to the table here, you can see that if it's extra small, which means I am catering up to 1000 IO points, then all I need is 12 core CPUs and 32 gig RAM, right? That means if you have enough capacity in your current existing existing cluster, you don't have to do anything for extra small monitor deployment. You have enough worker node availability for the monitor pods to run. But remember, the monitor also brings additional components. CP4D, the data warehouse is anyway we kept it outside, right? So you need to take a look at this is the minimum what I'm thinking we should be provisioning. But once you enable monitor, once you connect your IoT sensors for a extra small deployment, look at your cluster metrics in our Grafana tool or any other tool metrics or in the metrics tab. You can see all the how much CPUs used, how much memory is used by each pod. See if anything is spiking up, then depending upon that you have to fine tune your calculation or add additional worker node, move some of the CPU intensive ports to the empty worker node. So you have to little bit manage that. That's why I always say these are all estimation. You cannot exactly pinpoint number of worker nodes, but it's an experiment. You start with a really good number, and then you see how much you have to scale up or scale down. That is critical. So similarly, you have the small 14 cores and 64. So this is the core. I'm not talking here the number of worker node. This is just the amount of RAM and memory is used. So you calculate based on your worker node deployment. I can have 16 core 64 gig worker node, or I can have 12 core 32 gig worker node as well. So depending upon that, you need to make sure you have the number of worker nodes available. There was another session I did on the worker node deployment, how to calculate the worker node based on your core CPU requirement and core RAM requirement. So I will put that link to that video in my description in case if you have to refer that. Now This is the formula to calculate the IO points. This is the formula IBM given. This is their standard recommended approach. So IO points is equal to device matrix. This is the number of devices that is sending signals into monitor. Calculated matrix, this is the number of calculation that you are performing in the monitor application once the data is ingested. So you need to add both of them. So number of devices, which is not the assets here. One asset can have more than 3 IoT devices or devices sending time series or signal data. If you remember in architecture diagram, I have one asset which is a robotic arm, but I had 3 devices, right? So here the device matrix is 3. That means 3 devices sending matrix into the monitor. And this calculated matrix is the calculation, right? Suppose I want to see a median or mode of some data or some other calculation. These are a metrics. So I can define number of metrics per devices, right? Again, so if I define 3 metrics, that means in my example I have 3 devices, 3 into 3, that is I have total how many? 9 metrics. So you need to add those together and divided by estimated frequency per minute, right? So in a minute, how many ingestion is happening or how many calculations being calculated within the monitor ecosystem is the total result what we calculating as IO points, right? So this IO points determines the size of your deployment roughly, right? These are all estimation again, right? And then you can correspond that to a CPU core and RAM that will help you to identify how many worker nodes, what size of worker nodes you need, right? Whether to scale up, or if you have enough capacity, just leave it as is, right? If you are, as an example I said, if it's an extra small and if you have enough space, you don't have to do anything, right? You can just use monitor. Okay, so now let's take an example, good example of calculating IO points. In this use case or case study, a manufacturing facility has 3 robotic arms. Each of the robotic arm has 4 sensors sending metrics every 1 minute. That means we have 3 robotic arms. Each robotic arm has 3 sensors attached. So there are 12 total sensors sending signals every 1 minute. On top of that, the customer wanted to calculate, let me get the pointer. The customer wanted to calculate 5 metrics for each robotic arms. So 5 metrics for each robotic arms. That means 3 times 5, 15 metrics they want to calculate. Once the data has arrived, they want to calculate 15 metrics, 5 each. So in this case, how you calculate the IO points? So very simple, 5 steps. So device sending data is 3, that is 3 robotic arms. Metrics sent per device is 4, and we have 3 robotic arms. So total metrics, device metrics is 12. Calculated metrics per device, customer want to calculate 5 metrics. So there are 3 devices. So 3 times is 5 is 15. Estimated frequency that it sent is 1 minute, right? So if the frequency is 15 seconds, every 15 instead of 1 minute, right? If they are sending 15 seconds, all these sensors are sending every 15 seconds, then frequency is 0.25. So you have to calculate the frequency accordingly. Applying the formula, so IO points, this is the formula, right? So IO points is equal to device metrics plus calculator metrics KPI plus frequency per minute. So we already done a little bit calculation here. Now applying to the formula is this is the device metrics, this is the calculator metrics. 12 plus 15 by 1 is 27. That means this robotic arm sending signals per 4 sensors sending 1 per unit. We need 27 IO points. Same if the customer calculated metrics also added, which is 15 metrics, right? This is the calculator metrics. So 27 is the IO point. That means it's a extra small deployment, You don't need a larger deployment here based on the table that in the previous slide. If you remember, the previous slide has that extra small, so the IO points is falling below 1000 and that is extra. So above 5000 is the small deployment that we need. But what happens if these devices, these sensors are sending, instead of 1 minute, they are sending every 15 seconds, right? So again, it's 0.25. So if you go by IO points for signals for every 15 seconds, so you have to divide by the frequency here, and you'll get around is 0.25 actually, and it's around above 100 is the IO points. So this is just 3 robotic arms sending signal. There are four devices. But imagine you will, in your IoT ecosystem, you will have numerous devices sitting out sending signals at various time. So the calculation is not that easy, but it's not that complicated also. If you have a really good inventory of your IoT sensors, and you have a real understanding how these signals are, the frequency of these signals, and the number of metrics calculated for these each devices or each metrics data coming in, it's pretty simple to calculate by just applying the formula. But you cannot generalize and just say the whole organization has IoT, these many IO points. So you have to look at the device and kind of categorize them based on the frequency that they send. Find out all the IoT device that sends signals every minute, right, and group them together, calculate the IO points. Figure out all the IoT devices that sends every 15 seconds, right, group them and calculate the IO points, and add all those IO points. That will lead up to the final size. And you can use a previous table that I used, that's also available on the IBM site, and to figure out whether it is a small or extra small deployment. Then use that intelligence to by the infrastructure or tech team to make sure your cluster is properly sized. Normally, any deployment, you don't go immediately onboard all the sensors into monitor. It's a phased approach. You find the critical assets, try to onboard couple of sensors, couple of devices, couple of assets, and slowly scale up. Even that helps you to properly calculate the IO points, make sure your cluster is properly sized to take the load. The network is a big factor here, because we are sending time series data or signals to make sure the cluster is reachable and to all these places where the signals are available, connected. Usually don't directly connect to a signal device. Either it's a IoT gateway or that brings all the data, and we can use that IoT gateway to ingest information into monitor. So that's the overall how you calculate the sizing for health and monitor. But the overall, I just wanted to give an idea of what the architecture look like, what are the uses of these two applications, and some good practices on how to properly calculate or size your infrastructure.